Hi, I'm Tony, and this is Lab Time with Anton Paar. Today we're going to be talking about AAS analysis. Well, actually about sample preparation before AAS analysis. Why do samples need to be prepared prior to AAS analysis? Simply put, because atomic absorption spectroscopy can't handle samples in solid form. Solid samples can range from food, pharmaceuticals, polymers and metals to minerals, alloys and petroleum. Whatever you want to analyze first needs to be prepared. That means dissolved or digested. The result is a clear, particle-free solution in which all analytes are in solution. In this video, you'll find out what the three most important things are that you need for successful sample preparation prior to AAS analysis. You'll also get a link to a valuable database for preparation of individual samples. First off, which sample preparation technique is actually used? There are different methods of sample preparation. Today, though, we're going to focus on the most important and commonly used one, acid digestion. Let's look at the chemistry. What actually happens when we add acid to an organic sample? The acid, usually nitric acid, oxidizes and decomposes, that is to say digests, organic matter such as food, pharmaceuticals, polymers and petro samples. As a result, carbon dioxide and nitrous gases are formed. Trace elements that the sample might contain remain in solution, while the main components are destroyed. For inorganic samples like metals, ceramics and minerals, this process is similar. The difference is that we usually need acid mixtures. We'll talk about that later on. And that after the digestion process, not only the trace elements remain in solution, but also the main components. In both cases then, you end up with a dissolution of your analytes. Ideally a clear solution without any solids, which can be measured via atomic absorption spectroscopy. Regarding the required amount of digestion solution for analysis, it should be noted that flame atomic absorption spectrometry, in short FAAS, requires a lot of solution. For successful analysis of one element only, you will already need several milliliters. This means that for a broad element spectrum, it could be tight with a classic acid digestion recipe. In contrast, for graphite furnace atomic absorption spectrometry, several microliters of digestion solution are enough, which allows for acid digestion on a smaller scale. Now, how can you successfully perform a digestion? What do you have to observe in the digestion process for successful AAS analysis? First off, which acids do you need? Only a few acids are important for digestions. Which acid to use is defined by the sample. The most important question is, do you have an organic sample or an inorganic sample? Organic samples require mainly nitric acid for digestion. As a rule, 100 milligrams of sample require 1 milliliter of nitric acid. As we saw earlier, nitric acid oxidizes all the hydrocarbon bonds to ultimately form carbon dioxide and water, as well as nitrous gases from the acid. In addition to nitric acid, in some special cases, other acids may also be required. Hydrofluoric acid. Some organic samples may contain silicate. The only acid that can dissolve silicates is hydrofluoric acid, and so the addition of small amounts of hydrofluoric acid may be necessary. Hydrochloric acid. For analysis of mercury and iron, a small amount, like 1 milliliter of hydrochloric acid, is added to the solution right after the digestion in order to stabilize the analytes. Otherwise, they tend to adsorb to the vessel wall and the recovery rates are too low. Perchloric acid introduces even more oxidative power in case the nitric acid is too weak and the sample can't be broken down. Inorganic samples often require mixtures of different acids. The most common ones are aqua regia. A mixture of 3 parts of hydrochloric acid and 1 part of nitric acid is called aqua regia and is used to digest alloys or some noble metals like gold or platinum, although it can't digest all noble metals. Inverse aqua regia corresponds to a mixture of 1 part hydrochloric and 3 parts nitric acid and is less corrosive to the instrument equipment. For many applications, aqua regia can be replaced by reverse aqua regia. 4-acid mixture. Especially for geological and mining samples, a mixture of hydrochloric acid, nitric acid, perchloric acid and hydrofluoric acid is used for the total digestion of minerals. Additionally, adding sulfuric or phosphoric acid can also be helpful for digestion of inorganic samples like ceramics and oxides or metals and alloys. And of course, hydrofluoric acid is very often used since it helps in many cases to improve dissolution. It should be noted, though, that hydrofluoric acid can be an issue for the AAS instrument, since it causes damage due to its glass corrosive properties. Therefore, if hydrofluoric acid has been used, it must be evaporated before analysis, which is usually quite a cumbersome step. The good news for users of microwave digestion systems is, when using a microwave digestion system, hydrofluoric acid isn't so much of an issue. These systems allow for easy complexation of hydrofluoric acid with boric acid, and consequently, the digestion matrix can be analysed without hydrofluoric acid vibration. By the way, if you have solid samples, make sure the particle size is as small as possible, since powders are easier to digest than granules or pellets. But even if you use fine powders and the optimal acid mixture, you won't be able to digest your sample if you don't heat the whole mixture. A second factor that's crucial for digestions is temperature. There are 2 main reasons. First, a high temperature increases the oxidative power of the acids and improves the digestion and dissolution. Second, the high temperature decreases the total digestion time. Different samples require different temperatures for complete digestion. A few examples. On the organic front, aliphatic hydrocarbons, including heteroatoms, require temperatures up to approximately 200 degrees centigrade. Aromatic hydrocarbons, including heteroatoms, temperatures up to approximately 250 degrees centigrade. And inorganic samples often require even tougher conditions, up to 280 degrees centigrade for 1 or 2 hours. How do I reach such high temperatures, you may be wondering? Well, a hot plate isn't going to be enough. You need to close the vessels, otherwise the acid will evaporate upon heating. But heating a closed vessel to a high temperature will also result in high pressure. And for that, you need special instruments that can heat to and withstand high temperatures and the built-up pressure, which can reach up to 200 bar. Modern acid digestion instruments even suggest appropriate temperature time programs for individual samples. Such a method contains all important parameters for a complete digestion. Besides acid mixture and temperature, the sample weight and the heating ramp are also really important. The third factor to bear in mind is how to keep reactivity under control. For example, when you heat high amounts of a highly reactive sample quickly to high temperatures, the exothermic behavior during digestion may lead to an explosion because a lot of pressure is built up and released immediately. It's no joke. check out our video on heavily reacting cough mixture right here. The sample weight and heating profile must also be right. There's a simple rule: always play it safe. If you're sure about the reaction behavior and the reactivity of the sample, start with a very low sample weight of 100 to 300 milligrams and a very flat heating ramp. For example, take 20 to 40 minutes depending on the target temperature. The good news again is, as I mentioned, that modern digestion instruments have method libraries for individual samples, where all of these factors are already considered and preset, so you don't have to worry about them. But what do you do if you don't have a library on your instrument yet? Well, if you're not sure how to digest a sample, check out our free online method library. Just type in the sample type, for example, milk powder or crude oil, and you'll get a suggested sample weight, acid mixture, and temperature time program. And if you need to follow a specific standard, you'll find it there as well. These method parameters will help you to successfully digest your sample for accurate AAS analysis. Well, that wraps up today's video. Check out more lab time videos right here. From me, for now though, that's all. See you next time.